Our project is nearby robotic delivery. Our team consists of Andrew Potenza, who is an electrical engineering major, Roberto Sanchez, who is a mechanical engineering major, and Asher Hensley, an electrical engineering major. Our goal is to solve the last mile problem. Each day, there are about 25 billion packages, 3 billion of which are food deliveries. These packages are very proficient in getting to their destinations via vans and other delivery services. However, many landlocked buildings, such as in universities, have no way of receiving packages except by personnel delivery. That's where we come in. We plan to use our robots to autonomously deliver packages through sidewalk transportation. Our solution is to use our robots to provide an on-demand delivery service that allows students and faculty to get food and packages directly to them on campus. This will allow students to be more productive without having to waste time getting food and can have packages and food delivered right to them in landlocked buildings. Delivery robots is an emerging industry. There's already much competition. However, we have decided to take an approach that not many other companies have taken before. We use open source software as well as custom fabricated parts through methods of 3D printing, laser cutting, and CNC fabrication. This allows our robots to be much cheaper and easier to build to deliver packages and food. Our robot drives at about 4 miles per hour, therefore keeping up with pedestrians but not going too fast as to harm people. It can carry a maximum of 20 pounds or roughly the volume of 3 shopping bags. It is powered by an NVIDIA Tegra TX2 processor, which computes all the data coming from the LiDAR and other sensors. It has about a 2 centimeter localization accuracy to tell where it is in the world. It is able to detect and avoid stationary and moving obstacles such as cars, bikes, people, and even poles in the way on sidewalks. 95% of its running time is autonomous. However, it is always under human supervision and will always be monitored in case of fault. Our advantage is we are a cheaper alternative to traditional delivery methods, as well as we are an on-demand service. Use of robots allows us to eliminate the need for human drivers to landlocked buildings, as well as need for walking personnel. Most companies are trying to do autonomous delivery by drone. However, this causes problematic legality. By legality, this means that the FAA does not allow a drone operator to be without line of sight of their drone. Thus, autonomous drones are still not legal. Therefore, we decided to use a terrestrial robot to deliver packages. We custom fabricate our parts using things such as 3D printers and CAD software. Our CAD software allows us to model our parts before creating them, giving us an 80% success rate. Although human error is a factor which causes the success rate to be lower sometimes, however, the only other factor determining success rate is the machine's ability to produce the part. We have also custom developed and researched PCBs to allow us to have custom circuitry. We use Eagle software as well as a PCB CNC machine to allow us to CAD, create, and put together our custom PCBs to make custom motor controllers and be more efficient and cheaper. AI and neural network development is the main power of our project. This has allowed us to be an autonomous delivery service. Using data from the Z3D camera and the solid-state LiDAR sensors we have on the robot, we can create 3D cost maps of our surroundings of the robot. Our obstacle avoidance is done with 2D planar LiDAR, which can be represented in a point cloud array or a 2D map of our surroundings, allowing us to avoid obstacles that appear in this map. Our processing and data analysis is done by an NVIDIA Jetson TX2, which is a development board meant for artificial intelligence and neural networks. It uses an NVIDIA Tegra processor and handles all the data and information coming from the sensors and builds our custom maps to determine our surroundings. Cost breakdown of the robot totals out at $1,700. This is the cost to build a single one of our robots. However, there is an initial cost for the molds for the shell, marketing, and office and manufacturing equipment coming out to $4,600. If we were to total up the initial cost and make 12 robots, it would come out to $25,000. While this is a large number for 12 robots, this is much cheaper than the alternatives already existing in this market. Our future plans are to expand in nearby colleges such as FIU, Lynn University, and Nova, as well as optimize our current design for modularity and cost. We want to expand the product line and offer a larger package delivery robot, as well as autonomous transportation of people on campus. Once we have established a product that is working and is needed by people on campuses and markets nearby, we want to reach new markets such as airports, theme parks, festivals, as well as even indoor delivery. Thank you.